A customer sent in a Samsung mainboard for a UN65HU8500, and they're claiming that the HDMI ports do not work. So let's go ahead and live test it in our TV and find out why, so we can go ahead and fix it. So the TV we have here today is not actually the 65-inch HU8500, but it's the 55-inch 7000 series, which I'll show you how we're going to make it work. So I've installed the mainboard into the set, but I am using a 2 power supply system for this specific testing because we are using a slightly different set. So I'm going to use the original power supply to power up the backlights, but it's not actually connected. And then to power up the main board, we're going to use a different power supply for the UN65HU8500. So we're going to power that up, and then I'm going to go ahead and plug in my Fire Stick. Alright, so it turned on. We had our smart logo and we have our smart apps show up. So I'm going to go to HDMI 1, but it's not detecting anything. Even though my Fire Stick is currently hooked into HDMI 1, it's not detecting it. So HDMI 1, 2, 3, 4 are not highlighted, and they should be. So when I select it, it just says, this source is not connected. Please check your connection again. And that's the same for all 4. Okay, so we're gonna go ahead and remove the main board, and then we're gonna take a look at it under the microscope to see if we can find any shorts or defective parts. Before we start on the diagnostic and repairs, if you have a Samsung mainboard that you would like to send in for us to repair, we'll have links in the video description down below to our website where we have a flat rate service with 1-year warranties on all of our Samsung repairs. So on our mainboard, we have 1, 2, 3 HDMI ports, and we're gonna follow the traces. Looking at the bottom HDMI down here, it looks like the traces go straight to this chip over here. Let's see, we have our other HDMI 2, I believe, over here, which goes up and into this chip. And then we have our third HDMI, which goes here and again down into this chip. So my belief is either this chip or this chip are defective, perhaps both are defective. So what we're gonna do is check to see if they are shorted, and if so, we're gonna have to replace them. To identify if this chip has shorts without having to bring up the schematics on it and identifying every single pin, what they're supposed to be and what their rating is, what I like to do is just a bunch of short checks on the components around it that link directly to the chip. More specifically, the capacitors, because I know by default one side of the capacitor is going to be ground and the other will be leading to that chip. Now I'm not seeing a lot of capacitors linking to this chip on the top here. I see one right over here, so we could check this one. And that one is showing 6 mega ohms, so that's pretty high. That's not a short. We have this one over here, which is showing 0.764 mega ohms. So that's still very high. That's not a short. Because there's nothing else on the top, we're gonna actually flip the board over and we're gonna check the backside. So on the backside over here, this is actually the center of our chip. We have a lot of capacitors back here, and those will be linking directly to that chip. So we're gonna go ahead and check these. And here we have 27 ohms, 3 ohms. The reason I say that is because when I get a short by just bridging my leads, I still get about 1.5, 2 ohms. So if I'm getting 2 to 3 ohms with the multimeter, really what I'm getting is 0.5, 0.8 ohms. All right, let's go ahead and look at a couple of these over here. 4.5, 3.3. 4, 3, and it's kind of going up and down, and I just might not be making great contact with my leads. Yeah, 3 ohms. All right, so this to me is a clear indicator that this Panasonic branded chip or HDMI processor is bad and needs to be replaced. To remove this chip specifically, because it has a bottom ground pad, I will use my bottom heater and my top heat, which will be my hot air. But first, I want to loosen up and prep some of the pins on the outside of the chip, and we're gonna do that by just adding some solder with the iron. This is not necessary. I personally like to do it just so that I can get good flow on those pins first. And the reason for is I have had on occasion, if you don't heat up the chip properly on all sides at the same time, one of the pins may get stuck and not actually melt. So all of your other pins are molten and you can lift the chip, except there's a couple that are still soldered on. And when you lift the chip, it'll actually rip those traces off. So the reason I like to do this is it will give me a visual indicator confirming that the solder is flowing in all areas, so I can visually confirm it before I lift that chip. I'm gonna go ahead and put some flux all around, and we're gonna go ahead and start heating it up. So I have both my bottom heater preheating the main board from the bottom and my hot air from the top. So visually, we're taking a look. Does it look like it's molten everywhere? Not quite, maybe. It's looking like we're almost there. Ah. Gosh, that was quite ugly. I did not like what I did at all. So my tool was not sucking the chip up powerfully enough, so I had to actually scooch it up a little bit to offset it from some of the pads to then be able to lift it up. And during that process, I believe I knocked off whatever component was right there. I think that might be the extent of the damage. I don't think I had a component down here, but we're gonna have to double check. So real quick, while my board is still very hot, let's go ahead and clean up the original solder off. Well, original and I guess the new solder that I also added. Oh, yep, all right, let's take a peek here. I found it. This is our resistor. All right, so we're gonna put our solder paste on the pad in the center. Spread it around. Perfect. And we're gonna want to line it up as best we can. Oh, that's too much. All right, we're gonna push it back up from the bottom. And was that too much? No, that might be okay. Yeah, that's pretty good. Just gonna scooch it over ever so slightly. All right, that looks really good to me. So now we're gonna go ahead and heat it back up until we get to the melting point of the solder that we placed underneath the chip. And I'm just gonna be keeping an eye out on the chip to make sure that it's not shifting or moving, getting offset. Okay, and I think that's enough. Now we're just gonna wait for it to cool off. All right, the board has been given ample time to cool off, so I'm gonna give it just a slight nudge, and we just saw it move. So unfortunately, that means I did not reach the melting temperature, or I did, but the chip and the PCB did not solder properly together. Either the solder only attached to the PCB or only to the chip, but not together. So what that means is we're gonna have to do it again. This time what I'm gonna do is, while I'm heating it up, I'm also going to press down with this tool to ensure that the chip and the PCB are making proper contact. And I can see the solder here is, there's a little bit of solder left on a couple of the legs actually, and I just saw them turn more of a shiny color, which means that it is melting. I am getting to those high temperatures. All right, I'm gonna go ahead and put a little pressure, and we'll let it cool off. All right, so the chip has been cooling off for some time. Let's go ahead and give it a nudge. Yep, and it's on there, so I'm gonna nudge actually pretty hard here. And you can see the whole board just moved and the chip did not move. So now we know we have proper contact, so I can go ahead and go around and do the pins on the edges now. I'm just running the solder back and forth, and then I'm gonna bring it all over to one side where I can go ahead and remove that excess. Hopefully not too much. There we go, and we'll go ahead and repeat that process. I finished soldering all four sides. One thing I wanted to show you is I always double check, make sure that my solder joints are good. So using my dental tool, we're gonna rake the pins, just like that. And what we're doing essentially is we're making sure there's no loose pins. If there's a loose pin, then obviously it's going to get bent as I rake over, showing us that it is not soldered on properly, in which case we'll have to solder it on properly. Okay, and we're looking good. I flipped it over. Let's do a recheck of our capacitors. So we were checking over here, and now we have 99 ohms, 100 ohms, 256 ohms, 260, 260. So these, I think were the ones where we're getting 2.8, 3 ohms, 97, 96, 400 ohms. So obviously our shorts are now gone. We no longer have the shorts. I believe that we're good to go to reinstall the board into our TV and recheck live. All right, our main board is back into the TV. I already have, oh, and I can hear it, our Fire Stick. And now we have proper picture on screen. Let's go ahead and try the other HDMI ports. So let's take a look. So we were on HDMI 3, and now HDMI 4 is selectable over here. There we go. Let's see, HDMI 1. Our inputs. And it is also now selectable. And no HDMI. Okay, there it is. Let's go ahead and do HDMI 2 now. Same thing. And HDMI 2 is also again selectable. There we go. So that does conclude our repair. Again, if you have a Samsung mainboard you want to send in for us to fix, we'll have links in the video description below to our website and our flat rate repair services. If you did enjoy the video, make sure to leave us a like and subscribe for more content. Thank you for watching.